Hi everyone. In this video, we're going to study how to use the derivative to find the maximum and the minimum value of a function. Knowing how to find the maximum or minimum value of a function has a lot of real-life applications. For example, if we look at this example, if we look at this problem, sorry. A travel agency advertises that they will provide a mountain bike trip and a picnic lunch for $50 per person. They must have a guarantee of 30 people to do the trip. And furthermore, they agree that for each person in excess of 30, they will reduce the price per person for all riders by $50. And we'll ask, how many people will it take to maximize the company's revenue? So if there's only 50 people who are going to this trip, so if there are only 30 people who are going to this trip, now each person will be charged for $50. So the company's revenue gonna be 1,500. And if we have 31 person who are going to this trip, now because 31 person for 31 persons, here we have one person, in excess of 30. Therefore, each person, their price will be reduced by 50 cents. So now each person, the company charge each person 50 minus $50. So now each person is charged for $49.5. Therefore, the revenue now is 49.5 times the total number of persons. And that's how we get these numbers. Okay, so far it seems that the more persons who are going to join this trip, the higher the company's revenue going to be. However, this is not true. Why this is not true? So for example, if we have 130 persons, okay, now we have 130 persons who are going to participate in the trip. Because right now we have 100 persons in excess of 30. Therefore, the discount, every person will receive gonna be 100 times 0.50. So that gonna be $50. So that means the company will reduce $50 for each person. Now, because the original price is 50. The original price is 50. So 50 minus 50 gonna be 0. So now the price the company charges for each person is 0. That means the revenue is 0. So the company doesn't make any money. So therefore, this is not the case. Like the more customers, the more money the company will make. And actually, if we consider the function of the revenue, the graph of the function should be like a parabola. So we wanna, after, and in this graph, the x-axis stands for the number of the customers, and the y-axis stands for the revenue. So for example, when x equals 30, when x equals 30, the company's revenue is 1,500. Okay, and when x equals 31, the company's revenue is 1,534. So the revenue will achieve the maximum at this number. But after this number, the revenue will start going down. And when there are 130 people, the revenue is 0. So to find the maximum value of the revenue, we need to know, okay, what this number is. Okay, so this is a one example of using the maximum in our real life. Okay, so in this section, our goals are the following. Know the difference between local and absolute maximum and minimum. And when can we guarantee an absolute maximum and a minimum exist? And what is a critical point? So first, I would like to show you what's the difference between the absolute extremer and the local extremer. Here, the extremer, it refers to both maximum and minimum. And in some textbooks, we call the local extremer as a relative extremer. So for example, on website, if you see the word relative maximum, that means a local maximum. Okay. So here is the definition. The absolute maximum or minimum is the highest or lowest value the function can achieve on the specified interval. And the absolute extremer, it may occur at an interior point or at an endpoint of an interval. So based on this definition, if we want to find the absolute maximum of this function, that means we should look for the highest point, right? So the highest point is here. The highest point is here. Let me use a different color. So the absolute maximum is 3, and it occurs at x equals -2. And next, to find the absolute minimum, we should find the where the graph has a lowest point, and here the graph has a two lowest point, and these two lowest point, they are the same point. So the function has absolute minimum is -1, because for these 2 points, their y values are both -1, and it occurs at x equals -1 and x equals 4. Okay, now here is the formal definition of it. Let f be defined on an interval I that contains x equals c. If the function value f of c is greater than or equal to fx for every x in the interval, then we say f has an absolute maximum value of f of c on the interval at x equals c. If the function value f of c is less than or equal to f of x for every x in the interval, then we say f has an absolute minimum value of f of c on the interval I at x equals c. So because the function value at -2, f of -2 is the highest, right? Because it is 3 is the highest compared with any other function values on this interval from -3 to -4. So therefore, f of -2, which is 3, is the absolute maximum. And because at -1 or at 4, the function value is -1. -1 is the smallest in this interval from -3 to -4. So that's why -3 is the absolute minimum. And this time the absolute minimum, it occurs at x equals -1 and x equals 4.